Oh, and welcome to the Edge IoT Hub, sponsored by the Edge AI Hub and Newcastle University. Today it's myself and Rajni hosting. Rajni suffering 3 degrees hotter than Leeds in London. I'm melting at 27 degrees. I'm not used to this at all.
Yeah, we are learning new ways in UK here. For UK audience, probably they empathize, and hopefully everyone's keeping cool.
Yeah, so tonight we have Advait, who is coming from somewhere even hotter than us. Advait, how are things there with you?
Hey, hi everyone. I'm Advait here, Pune, India. It's like rainy season is touching, so we are enjoying monsoon and reading news about Europe. So hoping you will get a good season, something cold.
Great stuff. Rajni, you had some AIoT news to share with us?
Yes, thanks, John. So there was an event in London a few weeks ago. It's called the Edge. It's hosted by Edge AI Foundation. And this is a foundation of basically industry, academia, collaboration, predominantly semiconductor companies who produce Edge AI products are the primary sponsors, but everybody in the IoT community is, it's a big global community. And at the event, some of the observations I made, I thought I could share with you today with the audience. It might be of interest. Some of the stuff I saw was changes I've seen in the last 3 years. So for example, in about 23, 24, I'd seen a lot of people in the Edge AI Foundation talking about new architectures for silicon platforms, which would run ML applications, ML on edge, not just AI on edge. And this time, interestingly, I came across some startup companies and new companies who've already implemented these type of architectures on silicon. So what I thought was really exciting was the fact that a lot of edge AI devices can suddenly be made possible as a result of the AI coming on devices. And that's what checking ST Micro was featured as one of the European semiconductor companies, but quite a few other smaller players are there. If anybody is interested, I will be very happy to talk about the details or make connections with people who may be interested in knowing more about it. And I could also share a link if people want to join the community. They're welcome to do that. It doesn't cost anything.
Great stuff. We can put that in the comments at the end. So to help us demystify AI, it's a constant challenge. It moves relentlessly forward, and people have established ways of working constantly need to update, myself included. So tonight's talk is really very salient. I'm very pleased that Advait has joined us from Pune. Did I pronounce that correctly?
Yep.
Okay. Yeah, great. And you're going to be talking to us about IoT Data Drift Happens, AI to the rescue. So, normally I announce next month's talk, but we have a break in August, so we'll be back in September. So if you keep an eye on any of the meetup sites, join up there, you'll get notified when the next meetup are. So Advait, over to you.
Yes. So hi everyone. You can see that people are joining around the globe. So good morning, good afternoon, good evening to everyone. I'm Advait. I'm joining from Pune. And today I would like to speak about the data drift and AI. It's like, before that we'll start, just give a little introduction about myself. I'm working in Pune, one of the IT companies. And I'm having around 16 plus years of experience in different technologies. It started from AS400 to like SharePoint, .NET. And since last 6 to 7 years, I'm working in emerging technologies like IoT, artificial intelligence, machine learning, digital twin, etc. My core is like associated mostly into quality and deliverables, but at the same time, my experience spanning in development also. So in today's session, we'll start with the part on the, like, we know that when we're talking about emerging technology, we are talking about different technologies. It includes IoT, digital twin, augmented reality, etc. But when we're talking about this technology, we know that before, like around 50 years, when we're talking about any gadgets or any you can say appliance or anything, so people usually asking, is that a waterproof, is that a fireproof, something like that. So today, when we are talking about any emerging technology or any product, any gadget, or any you can say applications, then it's asking that the system is entirely AI enabled or how. So we know that the importance of AI is everywhere. So in today's session, we'll talk about the how we can go for the IoT data drift, and how we are coming on the AI to consider a rescue from any type of data drift in IoT. So let's move to start with the session. The agenda for today is like introduction to IoT data drift, defining data drift, then AI as a rescue, technical aspects, then quality aspects, architecture diagram, flow chart, and we are coming with a couple of use cases also. We'll keep going, and finally we'll look into the future trends and other information. So let's start with the part like introduction to IoT data. As we know that when we are talking about the IoT, we're talking about the connected devices like sensors, we're talking about machines, wearables, etc., etc. So these devices, when we are coming into IoT, it's constantly producing the data. This data is the we can say the lifeblood for these modern systems, powering smart cities, healthcare devices, energy grids, etc. So it's a huge number of spectrum. If we can talk about it, then it's like a huge thing which are connected devices, everything. So when it's coming into the use of this IoT application, what would happen? Like we are talk about the data, but it may possible that like whatever how we have developed the IoT application, how we have trained the data, but based on that, it may possible there could be the data drift happen. What is data drift? This application what on which we have trained the application, the data on which we have trained the application, and after the implementation or the deployment of that particular system, it may possible there could be a change. There could be an exception. There could be different scenarios which would come, and in that case, what will happen? There would be a difference or the mismatch between the data, whatever we have trained our application, as well as what the data after the deployment, it is coming as an input. So at that time, what would happen? It will be a data drift. So when we are talking about data drift, we need to look into the solutions also. So we know that in last, we can say 10 to 15 years, mostly like everything is coming under IoT, wearables, industries, different we can say different domains, logistic also, mobility, even in aviation also, in mobility also. So when I worked with previous company also, we were working on this IoT projects where logistic and mobility, they are like monitoring the data, monitoring the movement, everything. It's like a huge work on the IoT part. So mainly when we're talking about this part, the data is that's a statistical change. It's a normal thing. But the thing is happening in a way like when we're talking about the drift. So if we can say that in technical terms, drift occurs when statistical properties of input data change over the time. So there are several types of covariate drift happens when the distribution of input feature shifts. Like for example, if we're considering a thermostat, it will change as a there could be the seasonal reasons, there would be the different exceptions would happen. In that case, what will happen? There would be a data drift, and due to that drift, whatever the counts or whatever the measurements or the data we are getting, it won't be, there would be a mismatch in that. So at that time, we will get the results not up to our expectations, and it will be impact on the predictions, it will be impact on the accuracy, and finally it will impact on the decision making what we are expecting. So in this little diagram, we can see that in the normal, like we're consisting the stable data, then when the consisting sensor data is there, so temperature over the time, it's a normal pattern. But if it's come into any exception would happen, in that case, what would happen? That there would be drift would be into the picture. So in that case, what will happen? What the flow we have talked about. So it will started coming, like what data we get, what the information we are getting, what the results we are getting, and based on that, there would be the change in the accuracy, and there would be the change in the decision making also. So how to tackle with this? So in that case, AI as a drift rescuer. So let's talk about rescue pattern. So AI is the hero in this story. We can say hero. That's okay, but it's a hero in every story nowadays. There would be AI only. Every day we are reading news about that. But yeah, so AI detects the anomalies. We know that AI detects the anomalies by continuously analyzing the IoT data streams. AI can flag. So what would happen? AI can flag. It will create an alert. It will give we can say it will raise something like, yeah, there is an anomaly, and you need to consider, you need to look at it. So by continuously analyzing IoT data streams, AI can flag when distribution deviate from the expected prediction, ensuring models stay aligned with the reality. This retraining, this pattern, or when we are talking about this data stream, it's into the pipeline. So what AI is going to do? It's going to work across each and every stage. It is identifying, it is monitoring, it is raising the bar, it is providing the solution. When it's coming into that part, then it's considering that data, it will take that data, and based on that, it will start retaining it. So it's not just about the one part, like you have implemented the AI and you will get that part and its role is finished. That is not the case. Every time what would happen, whatever the domain or whatever the system you have implemented out there, from its A to Z part, in every stage we can consider AI as a rescuer. See, the thing is that it's not about the any first particular stage because of that, or which is going to impact the particular decision making. It's a huge thing. We initially in the first slide we talk about that data is a lifeblood. So everywhere there is data. So every data has to consider, right? So yes. So in that case, what would happen? AI is something which is considering in each and every stage. So technical aspects of data drift detection. So this diagram will be easy for everyone to understand, right? It's a normal. We can see the architectural part also, or it's a flow diagram, normal flow diagram, but it will be easy to understand. So drift detection is the first line of defense in IoT and AI system. The process begins when data ingestion pipeline. So it is started. It's like gateways and brokers. We can say that the message brokers. We're taking an example. There could be the different systems or different architecture would be there. But the Kafka stream telemetry images or sensor reading into a data lake. From there, the data monitoring tracks feature distribution and builds baseline. So that is initial state. Then the drift detection engine. So we are implementing here the drift detection engine. Applies statistical tests such as KS or chi-square. Okay, so we can consider the another session for that because it's a huge one, like KS or chi-square. But who are not aware of this, we can say statistical test, it's general to consider the pattern. The pattern could be into numbers or into groups or into some type of we can say a class of that particular distribution. So these statistical methods helps us out to understand that and to compare the incoming data with the training data. A distribution diverge drift in suspected in parallel real-time anomaly detection. So in previous slide we saw that like each and every stage we are considering AI. It is not something at a specific stage. But when it is coming to real-time anomaly detection using unsupervised models like autoencoders, continuously scan the streams of that particular data. So who may are not aware of this part, maybe. So just giving a quick line that there are different type of learnings like supervised learning, unsupervised learning, and reinforcement learning. So when we are getting that data, we are considering here that particular type of learning is started with autoencoders, that is unsupervised learning. And when drift crosses the threshold, the system generates alerts. Okay, now system will generate alerts that ranging from the informational or we can say that it's a categorization. It depends on domain to domain or the system to system, or maybe who all are like we have to define. It's a customized one. So based on that pattern, we can consider it's a simple, it's a critical, it's a medium, whatever. And finally, what would happen? The actionable insight drive remediation. So retraining models, scheduling audits, or adjusting edge configuration, that's the key gateways. So when we're talking about the technical aspects, it's a simple flow. It's a simple flow, but at each and every flow, what we know that we need to take it carefully to consider it, while because there is a huge data, and based on that data and how your system, how your AI application, whatever the system you have implemented out there to consider to work on the data drift, at that time what would happen, it will give us the proper and smooth run of that particular IoT pipelines. So quality aspects, testing and governance, that's a good thing. But the thing is that when we are talking about the quality aspect in normal software testing, also when we are talking about, the thing is that it's a big one. It's not something like that we are talking about the functional testing or the performance testing or the load testing, something like that. But when we are talking about this quality aspect in this particular domain or particular technology part, at that time what would happen, it's a backbone of entire drift management. Accuracy checks the ensure retrained models perform well. Reliability testing confirms the predictions remain, what we can say, that prediction remains consistent under varying conditions. So n number of test cases would be there, n number of quality parameters would be there. So accuracy and reliability, yeah, that is of course there. The fairness and bias monitoring, yeah. So this is the very nice word, like fairness and bias, because always when it's coming into AI, these words are coming like a shadow. Yes, fairness and bias. So if we're talking about any IoT application, suppose it is from healthcare domain, then it should not come with the way like it's a representing so any particular demographics or any particular group of people. So what would happen, it won't work accordingly based on what we have designed it. So it started from there only. When we're talking about healthcare, there are regulatory compliances. Different geographicals have different regulatory compliance, so your system should meet that. Continuous validation, yes, continuous validation is required. It is for each and every domain, I would say, or each and every system. So continuous validation should be there. Governance frameworks provide oversight. So this, what would happen? Like we have defined the governance framework. We have developed our own. Maybe people are using different technology or APIs they are calling, and they are providing that framework, and they're calling that data and giving in a way like if any alert is there, any particular point which need to highlight. So it may be something like that, it will come on the dashboard or it will come to your email, some anywhere. But constantly it should come, and it's like when it's coming to AI, it means that your testing practices or your test quality governance should work in a way like time to time it should come and it should get analyzed. So for that, the final should be auditing. So proper auditing, without auditing, it won't come to an end. Like it's a comprehensive cycle of that. Okay. So it's a quality aspect of testing and governance for that. So let's move to architecture diagram of this part, like how IoT and AI drift handling it works. So let's before going on the diagram slide. So IoT devices, drift detection models, retraining pipeline, quality assurance layer, AI governance dashboard. So these are the simple, we can say it's a 5-point where the entire process we can consider. Okay, so yeah. So it's easy. I try to make it easiest to understand for people who are just coming into IoT field, or maybe like trying to understand the IoT while they're trying to switch their maybe domain or their technology practices. So when drift is detected, data flows into retraining pipeline. So quality assurance layers validate the retrain model. Finally, governance dashboards provide oversight. So if we need to explain this diagram in those 5 points, so it's a simple that IoT devices generate data. Okay, detection modules flag drift. Retraining pipelines, what they do, adapt models. Quality layers safeguard accuracy and reliability, what we have seen on the quality and governance slide. Quality layers safeguard the accuracy and reliability. And finally, governance dashboard ensure accountability. So in a simple way, like whenever the data ingestion is coming out there, it's monitoring, it's analyzing the data, it's checking the data. After checking, it needs to work on that. So you need to you need to check the drift, if drift is happening and what type of drift is there. So all the data related to drift should come there. So in other way, we can say that some metadata of that particular drift. So that metadata should be analyzed properly, and after that it will come on that way. So it's a, together they are forming a holistic system. This holistic system is not just a design, it's a strategy, we can say, in other words. Okay, so this diagram, what it's saying, like it's a system into system, or the system on the system, where IoT devices and AI are working together hand in hand. So in it, it ensures that the drift management is, we can say, systematic and not ad hoc. And finally, like we always know, like quality, it's must, right? It's not an optional part. So it started from the development team or the management team or your stakeholders. Everyone is involved in that part, and it started to work in a way like whatever the you can say the governance dashboard is showing finally. So that's the part of concern. Okay, so we have seen each and everything about that, like how AI is coming out there. But like before going into further details, we need to know about the drift life cycle. So that is the main part of our, we can say, in today's session, that the flow chart which is showing that the how drift life cycle works. So I think this diagram I try to make it more easy. So it's self-explanatory, but let's go step by step. It begins with the data collection. Okay. Now, IoT devices stream inputs. Drift detection modules monitor these streams. When drift is detected, alerts are generated. Okay. Now, what happened? Like there could be a manual aspect. Mostly, it's into the practice. It's an automation aspect, but maybe like a team or the we can say engineers or the automated system triggered the retraining. Models are retrained with the fresh data. Now, validation ensures retrained models meet quality standards. In last two slides, we have seen that the quality is not an optional part; it's a must thing. So it's sorry, it's quality standards. Then redeployment puts updated models back into production. It's a normal practice what we are doing. The cycle repeats continuously. So once it's done, keeps going. It keeps going. Now, this life cycle shows drift is not a one-time event, right? Because we have seen in initial slides, see how these slides are connected to each other. That's when we are started, we're talking about the data. Data is a lifeblood. So similarly, its IoT system must evolve constantly as the data comes and the new things are happening, the new patterns are coming, what we have seen in case method. So similarly, it will keep happening. And the life cycle shows drift is not a one-time event. We see that it's a ongoing. Now, AI enables this evaluation by following the life cycle. So drift we have managed, but it's not a normal management of the drift. It's entirely AI enabled, or we can say with the help of AI, we are managing it. It's a loop of vigilance, or we can say the loop of what we say adaptation. And finally, obviously, what we talk about the system is working, but our results and the final output coming from the system means the system is meant to work for that particular operation or the particular process. At that time, it's going in a way like it's providing the validation to that. Okay. So I think when we're starting from this data collection, drift detection, everything, so baseline model, what we have done here, then how it's coming, how the new model is generating, how the data is coming, and how your AI model is monitoring that. So each and every stage there is an AI. So we have seen about like what is drift, how it works, how it happened, why it happened. Then we have seen that the drift life cycle. Now we move into real time, or we can say the real world use cases, where we know that drift happens and how we need to handle it. So before going into use cases, we'll talk about the initial part of use cases, that the comparative analysis of use case. So it's a we are taking the use cases of smart grids, smart cities, example healthcare, retail. So in smart grids, we can see that there is a seasonal drift happen. Like there could be a different pattern in the grids, in the use or in infrastructure. It could happen, and in summer, in winter, in it's a seasonal dip. Like it will be behave something different in one season, something different in another season. Similarly, in the smart cities, behavioral drift. So we'll take an example of traffic system. We know that the post-pandemic, pre-pandemic, the conditions were different. Like we're working on moving to work from home, or we're visiting office. Like initially, it was carpool. So we can say the number of cars or number of four-wheelers is restricted on the street. But like when it's coming into quarantine or each other and many other conditions, at that time it would happen like the traffic pattern would be different. In healthcare also, we are using wearables. We are using health watch, that is smart watch, and other gadgets. But like when we are getting that, we are using it for while exercise. But at the different we can say age group or the change in health, change in lifestyle, it will give us the lifestyle drift. In retail also, there is a consumer drift. Like when it's a festival season, there could be a different pattern of shopping. In non-festival season, there would be different pattern of shopping. When there is a sale, at that time also there is a different type of shopping. So based on that, it's coming into different type of drifts. The common thread says drift is there, but always like we're talking about drift, it's AI is there to rescue that particular drift, or we can say it will help us out to come out of it. So drift causes we have seen here. So you can quickly read it out. In smart grid, like seasonal demand shifts, weather anomalies, population growth, renewable integration, we can say behavioral changes. Then smart city traffic, as we said, like remote work trends, event-driven surges, infrastructure changes, maybe government policy shifts, mobility adoption. Then retail also, seasonal shopping patterns, what we said about festival, non-festival, or the sale season. Healthcare also, like lifestyle changes, medication effects, age progression, environmental and other factors also. So this type of maybe we can say this type of causes are there behind these use cases we are considering. There could be different type of use cases are also. Recently, I read one article. I don't remember, in one of the blog sites, that they use cameras to enter people, like allow people only to attend that particular event. And in that case, it may possible that you are passing your ticket or your entrance pass to someone. So it may cause any big problem out there. So at that time, what they are using this IoT, they are using these cameras, and based on that, they are like identifying people, that particular count or particular looking at the particular faces or other information. So it is working very smoothly. So this is another diagram. AI to the rescue, bridging seasonal smart grid drift. The problem says IoT data drift happens. Yes, we know that. There could be different season, different energy model, right? Seasonal drift. In the start of this session, that was not the part of our agenda, but like John and we were talking about this part. Rajni was saying like it's a heat out there in Europe, as we know that. So it's we can say that the seasonal changes, it occurs. Like initially we have seen that the seasonal drift occurs, static model mismatch, mislocated resources. So number of things are there. So initially in previous slide we have seen that. So there are different causes of particular drift. So energy grids are classic example. We can say that smart meter collects consumption data. Okay. Now AI models predict demand, but the consumption patterns vary seasonally. Your model trained on the winter data won't work on other you can say other season or exceptional season. Like suddenly it will be cold, suddenly it will be hot. Anything could happen. So by retraining the model with fresh seasonal data, adaptive learning entries predictions remain accurate, and quality checks validate the retrained model is working as expected. So Thus, when we talk about the autoencoders, they are like unsupervised learning. They are getting the data and they are reading it, they are analyzing it, they are understanding it, and based on that, our models get trained. And now the duty is only to check the quality, to validate it, and after that, what would happen? We are deploying that system, and it's giving us the we can say that final output that yes, system is working fine with the help of AI. So that part, then smart city traffic use case. This is another real world use case. Like in most of the cities, they have started using this IoT on the signal system, cameras to monitor the things, what is the traffic pattern, and how the things are going. Like what could be the if there is any hodgepodges happen, then what could be the possible reason? Is it something like something weird happened, or it's anything could be the cause for that. So smart cities rely on IoT sensors to manage the traffic. We can say that the AI models predict congestion, they are optimized signals, but commuting pattern dramatically change after the pandemic. Like initially we talk about that. So we can say remote work reduced the peak hour traffic. Mobility trends shifted towards bike and share rides or models trained on pre-pandemic or data drifted. So prediction became inaccurate. So AI rescue by retraining the models with we can say with new data. So whatever the data we're collecting, based on that, the models start learning that IoT sensor fit real time we can say the real time information, real time data, and based on that data our model gets trained, and based on that the next time what would happen, like it's a continuous process. This will keep going. So more and more data would be there, more and more pattern would be there, and it will help us out to train and meet the system to the expectation. Like it's a giving the it's 100% to meet that expectation. So we are again in this case also we are coming with the quality checks, validate the retrained model, and governance frameworks to ensure fairness and compliance. So similarly, it's again what we can say that the retail and supply chain. In initial slide also we have seen that the shifting consumer behavior and pandemic drift, but it's not I can say that it's not about only the suppose it's a pandemic or something, but depend on what we can say the different schemes, different offers given by online portals, and they are providing the different what we can say different offers to consumer to get on their website and get the buy more and more products. So based on that also it happened, like it's not always connected with the pandemic, but pandemic is one of the event which has changed many things. So this is one of them. So now what would happen, like it's giving altogether a different perception towards that particular domain. So perception in that domain has changed. Similarly, whatever the systems we have implemented, whatever the automation systems we have implemented there, those are also changed. So what we can say that the retail and supply chains rely on IoT. Okay, so sensors for inventory tracking and AI models for demand forecasting. Now, but consumer behavior shifts cause drift. As we say that the pandemic accelerated the online shopping, or it's giving a boost to e-commerce, it's reduced in-store shopping and alter the product demand, we can say. The models trained on pre-pandemic data become inaccurate, obviously. But this is not, again, I said that this is not for the any particular event. It's keep going. Time to time, it will be like it's something new is coming, something new wave is coming in the field of e-commerce, and it's changing the pattern of each and everything. So it's a what we can say that type of if drift is coming out there, then it's touching to or is disturbing. In other words, we can say disturbing or changing the pattern of supply chain. That AI rescues by retraining the demand forecasting. So how the things are going, how your logistic, how your warehouse is there, and what is the infra you are built for that particular particular domain requirements or the components of particular domain. So in that case, what would happen? It's AI is there, like it needs to monitor each and everything, and it's considering that every aspect of that particular cycle. Okay, so it's like IoT sensor provide real-time inventory data, adaptive learning generates forecasts, reflect current behavior, what's going on. So each and everything would come in that circle. Whatever circle we have shown, so each and everything is part of that circle. And because of that, what would happen? AI in true sense, the word we have used, that AI is a hero in this drift management. So healthcare IoT case for the drift detection. So wearable monitor health metrics and drift occurs. So initial health patterns and lifestyle drift. So in initial slide also we check that there are different type of possibilities, different type of scenarios or causes which are bringing the drift. So like we are using the IoT devices like wearables monitoring heart rate, blood pressure, activity, and other details also. Like people are using the smartwatch, they are going on running and they're constantly checking if there is any alert, like my steps are blah blah blah, and if I'm like not meeting my expectation on that part. So drift threatens the patient safety when it's coming on the normal human being also, or it's a patient also. So AI rescues by retraining the models with updated data. The we can say adaptive. That's a very nice word. That's adaptive learning ensures accuracy. Again, I'm saying that on the quality, that accuracy and reliability. And quality governance prevents the bias, because as we said that the regulatory compliance are different on the different geographics, maybe human to human, different age groups. So that is required, and we need to ensure that we are meeting to that. So continuous validation maintains the trust. Without AI, drift risk is like it's something where we are misdiagnosing something, and healthcare IoT remain reliable when there is not a drift and it is working as expected. Because see, every domain is important, every system is important, but when we're talking about some a couple of things where it's directly coming with your close close to human being, like when it's a healthcare, banking, finance, these aspects are where we're caring more about that, obviously. So it's coming in that way. It needs to implement, it needs to use the AI to handle that. See this image carefully, this diagram. So we are considering here the we can say that unique example where IoT has been handled with AI to manage the drift. So we have started with this. It's a somewhat smart ECG wearable. Okay, so this is in three colors in this diagram. It started with the blue, then it's a gray, and then it's a this green part. So what is this blue section? We can say that this is where the data generation begins. We use the smart ECG wearable. The smart ECG wearable as our primary example, we can say, for this particular case study. So which continuously captures the vital sign sensor data. This data is often transmitted through different devices. We can say the patient mobile, that's the gateway. And now we serve as a secure gateway, as is then stream in the encrypted format to the cloud. So why drift occurs here? So we are talking about it, but why drifts occur here? So it may be sensor degradation, electrode wear, or sudden patient lifestyle changes. That could be anything. Okay. Now, in cloud ingestion and data lake, the same diagram we have seen where when we are talking about the normal flow of this data drift, while we are understanding that. So the layer handles the high velocity data. The message broker, MQTT or Kinesis, there are other also, but like these are when we are talking about majorly, we are considering this part. So message broker message the massive incoming data stream. The data follows two paths. One to the cold storage, raw data lake for long-term storage and archiving. So it would be something like it's not going to legacy system, we can say, but it's archival data. And another is optimized path for the speed. So which is the data which we are considering further. Then the optimized path uses a feature engineering service. So that feature engineering service, what it is doing, it is actually working out there to clean the raw data before storing it into high speed feature store, whatever was shown in the diagram. So this is how happening in the, it started with the blue, it's going into the gray. Now we're coming into the picture of AI and ML operations engine and applications. Exactly. This is the core intelligence of the system split into two crucial sub processes. Okay, so this process, it is started with like deployed model inference. This process provides the core value. Okay, the clinical prediction API. We know that the most of the things we are considering, we are working with using APIs. So it's a train to detect the heart arrhythmia. So it pulls features from the feature store in real time. So whatever the data we have there, we have cleaned that data and we are using that. The predictions are generated by the online inference services. The final insight are sent to end user application. Like it could be a patient, or it could be like a doctor who is like treating, or who is like working on the diagnosis. He will get a dashboard where the information would be there. In below box, we can say that the data drift monitoring, that AI solution, how it's working. This sub process runs simultaneously with the inference engine to ensure accuracy. The drift detection engine continuously analyzes statistical samples. Okay, of that we find features being fed into the what we can say the active clinical model. It compares them against that historical baseline using methods like we talk about the statistical test case. Okay, chi-square. So checking if the probability distribution of incoming numbers has shifted significantly. Okay. Now the model reconstruction error, if using that in AI, like we are talking about unsupervised learning, that autoencoder to monitor behavior, a sudden spike in its error rate indicates unexpected input. So when a significant drift is detected, the engine generates the, like we have seen here, shown here, the dotted line in the orange color. Okay, so thus the entire system works at the different places, different framework or different technology, different APIs we are calling, and it's working. So it's again, it's not a one-time thing, right? It's a continuous part. The drift alert triggers the automated model retraining pipeline. The pipeline, we can say, automatically fetches the fresh data from the data, combines it with the required historical data, and often pulls a fresh data, that verified clinical level data. Now, the model training service uses high performance GPUs to quickly, what we can say quickly, it's immediately started retraining the clinical model using this updated and shifted data set. So now the new data set has created out there, and now based on that, it started retraining. Once validated, this updated model, what happened is deployed directly back to the clinical prediction API and replacing outdated model. So it's help us to resolve that entire process, and it will remove that gap, and it will finally resulted into the removal of the drift. So this is one of the case we are considering, the entire process where how it's working and how it's coming AI for the rescue. So there are again some couple of tools are there which are specific to this part of what we can say the use cases we have learned. But apart from that, there are n number of things where we are using IoT, where we are using AI-enabled IoT. So these are the simple. Everybody knows about this. That TensorFlow, different Python library, different APIs there. The Google Vertex AI, IBM Watson. I'm just taking these names. There are again many frameworks are there which are easily available. You can check on the Git also. So based on the requirement, maybe domain specific or the scenario specific, we can use those. Future trends in AI and IoT drift management. We know that the future trends, there is a like federated learning for IoT. Now federated learning is coming. It's what we can say. It's the next big thing we can say. It allows IoT devices to train models collaboratively without sharing raw data. So where people are talking about data privacy, data security. So it's without sharing the raw data, enhancing the privacy. Edge AI. So Edge AI is something which is again next to big thing. Like when initially we have started this session, Rajni was talking about the tiny ML. Yes, so it is coming in that way. Like it's a low latency decision making, continuous model optimization on the device, immediate data cleaning, and rapid response to changing conditions. So directly you are getting that particular edge AI to your system or your entire application, and it is directly started working. So it is minimizing the latency. Explainable AI for governance. So yes, it is helping out, that like it's explaining, it's providing the information in the right way, and the most important part is the presentation and the it's clearing everything, that it's interpretable model prediction, understanding why models drift, and regulatory compliance. So it is meeting where we are talking about the legal part of the system. Yes, we are meeting that, we are considering that, and it's why it's important. Actually it is more important because it's building trust, and the trust is not about only about for that product or the technology. It's directly bringing the impact on entire business and stakeholders. It is one of the aspect which is important. People are not talking much about it, but when it's coming into AI into picture, bias fairness, these things are also important than explainable AI, because it is directly impacting on the ROI, that is return on investment. Then automated pipelines with minimal intervention. So yeah, this is the common thing. Many IT companies have already started this practice, and many of them are like implementing this. Everything is into automation. And the continuous evaluation of IoT ecosystem. So initially, whatever ecosystem you have built for this IoT, it's keep evaluating day by day or over the time. It's a normal thing, like it's happening. But if any exceptional or any scenario-based use case would come, yes, it has to consider that, and quickly you need to shift from whatever your regular practice. You need to meet that. Yeah. So the part of conclusion, like it's like we have seen everything, but like drift is inevitable in IoT. AI rescues through detection. We have seen that the detection, retraining, governance, continuous monitoring, and again working in that cycle. So AI is always there to help us out. We have seen the real world cases where in the different use cases having different scenarios, different exceptions, and they are handling with the help of AI, and how IoT is using out there, and how AI is helping them. Future trends also, we have seen that it's promised the autonomy, it is building the trust, and it is providing the proper solution. So yeah, here I'm Advait. You can connect me anytime. Like we're having these practices. I keep writing, keep talking in different events. So if any query in this part, if I can help you guys out with that, then I always would be happy. So yeah, over to you, John. Hello.
You're on mute, John.
So the question I've got could be summarized as you talk about drift detection, anomaly detection, statistical analysis, performance decay, prior probability drift, triggering model retraining. There's a slight nod at data governance. How much is the human in the loop in all of this process? How much is the human gating moving to the next stage? Okay, we think there's an anomaly. How do we verify the anomaly? Who do we alert? How do we retrain the model? Is the human retraining bits the model? Is it automated retraining? Once we got a retrained model, is it automatic deployment to production, or is someone gating that and saying, we want to do some additional QA before it goes into production? So where's the human fit into all of that?
Yes, no, very nice question. I must say, like in one of the slides we talk about that. So when it's coming into retraining of that particular cycle, like data stream is coming, it's going. At that time when alerts are generated and the data is coming into pipeline, when retraining is started, so what type of the drift is there, and what is the percentage of drift? Because we are getting each and every data, we are getting analysis of that, and we are getting results on dashboard. So whatever the model we have, there are two aspects. We have automation in place. Yes, we have automation in place. But a team of, I'm using the word engineers, but team of experts is there. 1 second, battery is low. Okay, so team of experts is there. So at that time, we need to trigger that. For triggering that retraining, it may possible that you are putting some type of sub alert, because initially alert is there, so we need to put a sub alert. That sub alert, see, it's a entire AI system which has been implemented, because this sub alert also is depend, because its AI is monitoring that. So our framework we have built, or our subsystems we have built, these are working on their own, but at time it may possible that the results are not expecting, results are not meeting, the accuracy or quality is not there. Suppose you have written the test cases and you are identifying that your system is working. So it may possible that we are doing the exploratory testing. Exploratory testing always need a human hand. So in our exploratory testing, suppose into negative testing also, monkey testing also, we are considering that, yeah, so human coming into the loop. And when this is not giving the result, again the experts are coming into the loop. And in that case, what would happen? Our retrain, the model what we have developed, we need to upgrade that, we need to evolve that, because we are not meeting the expected results.
Okay, yeah, I think it'd be a very interesting thing, just how you go about generating that drift detection module. But I think that's another hour-long presentation. But I could see how you could generate that as part and parcel of the model. You say, well, we've got this input data, it's within these barriers, these boundaries, and if it drifts much outside of these boundaries, then we need to alert and potentially retrain a new model. Very interesting.
Yeah, right.
Yes. Thanks a lot for the talk, Advait. I had one question as well. Most of the drifts, the examples that you explained, are expected drifts because of either change in seasons, change in behavior, and so on. But there could be unexpected and undesired drifts as well. For example, degradation of electronics. I'm just taking an example, can't think of something else. But is there a different approach to managing such drifts where the drift is unexpected? Unexpected, yes. As in drift itself is indicative of quality issue, not behavior issue.
Correct. So I must say that's a very good question. Expected and unexpected. So between unexpected and unexpected, there could be like simply two things out there. First thing is, it's an exception. We have not expected it, right? So every time, what could be the expectation exception? Any damn thing would be there. But my system is handling that. How it is handling that? It is grouping it into one. It is adding it into one group. So I'm taking a very nice example. Okay, you are traveling through expressway. Maybe it's London to Leeds or anywhere. It's an expressway. Now, what would happen due to thunderstorm or due to hurricane? There is some big rocks are on the road. Now there is a traffic jam. It's a hodgepodge. We know that it's a traffic jam. It's a unique case. That is a traffic jam. That I know. It's very sorry, not a unique. It's a very generic. It's a traffic jam. The cause behind that, I don't know. That could be anything would be coming to the cause, right? So now that is what I'm doing. I'm putting that when I'm not understanding what my system is not understanding what's going on. I will take it. I will make it into a group where it will become under that exception. And that exception will be handled in a way like it's creating an alert and it's saying that something different is there. It's not a normal thing. So based on that, you can create your further plan to work on that. So similarly, another case there in one of the carnival, I recently read that in one of the carnivals, what they have done is the same example I talk about, where we don't know like who all are there, who all are joining, because I have distributed pass. And now the pass is not a passable, like no one else can use that pass. The only person who is allotted that pass, he or she will enter there. So my system, my AI cameras, what they would do, they would identify based on the information, like I have filled the information. The only thing is that when we are, it's not the case like we are having that barcode. it would be your face recognition normally, and based on that, yes, the person has entered. Now the thing is that there are n number of people. Suppose there are 100 or 150 number of people, and your cameras you into the drone, and they are moving everywhere, and they are trying to cover that particular entire area. Now what happened? Suddenly one face was there which was not identified. The data was not already there. Okay, now data was not already there. Now there are two scenarios. The data is not there. It means that the person is not invited, and he came forcefully, maybe on some other pass ticket, or maybe by other way. So at that time we need to raise that alert. So here again, it was not it's not in a way like we were expecting that. Now third example, in my bungalow, I'm not staying in bungalow, I have a simple flat, but in my bungalow, if I put some security systems, and my bungalow or my farmhouse is away from the city, now my cameras should identify someone is in my premises, he is a human being or not. Suddenly one day what would happen? There would be a leopard or some other animal, werewolf or bear, anything would be there. So based on that, my alert should work. So it was unexpected. Like, you are considering like the cameras or your system is only for the human being, but now human being is not there. It is something which is not expected. But on that case, what you are going to do? So you will simply get the alert. Oh, someone is there. So this is not the case. I am opening door and I am going. Oh, who is there? Oh, werewolf. So till the time I am completing my word werewolf on the last alphabet, it will get on me.
Fantastic. I think we can call it there just before time. Just a small reminder that August, we're on a break. I think most of us go away for August. I certainly do. If you've got any talks that you'd like to share with a thriving IoT community, please get in contact with either myself or Rajni. We'd be delighted to discuss any ideas you have. Just remains to say thank you much, Advait.
Thanks, Rajni. Thanks, John.
Thank
Have a
you.
great day, and looking to meet you guys in future. Stay connected.
Yeah.
Of course.
Thank you again.
Good evening,
Thank you.
everyone.
Yeah, bye.